Hello everyone. Now we are going to learn about basic vhdl program for full ladder in structural style of modeling. Full ladder, it is as a black box, full ladder as a black box, and it has three inputs A, B, C, and performs addition of 3 bits. Sum and carry are the outputs of this full ladder. So A, B, C are the inputs, carry and sum are the outputs. So with the three possible inputs, we have 2 power n input combinations. Therefore, ABC 000001010 like that up to 111, we have input combinations. And when we perform addition of these 3 bits, what is the sum and what is the carry, we write here. So 000 plus 0 plus 0 plus 0 is sum 0 with carry 0. 001 sum 1 with carry 0. Like that 111 sum 1 with carry 1. So in this way, we write truth table for full ladder, and then we realize the Boolean expression for this sum. So sum is equal to, we take all the terms and we simplify it through K-map or by using Boolean equations or Boolean theorems. So sum is equal to A bar B bar C plus A bar B C bar plus A B bar C bar plus A, B, C. So when we simplify all these four terms, we'll get A XOR with B, XOR with C. Similarly, we take carry. Carry is equal to A bar B C plus A B bar C plus A B C bar plus A B C. So when we simplify it using K-map or by Boolean expressions, we'll get carry is A and with B or that means carry is equal to AB plus BC plus AC. Here plus should be there, plus AC. And A and with B or B and with C or A and with C. So like that we write 2 Boolean expressions for sum and carry. And when we realize the logic diagram, A exclusive OR with B, that is S1, and S1 is exclusive OR with C in. So finally we get sum equal to A XOR with B XOR with C in. And similarly, we need 3 AND gates for 3 product terms A, B, B, C, A, C, and their sum is required. Therefore, OR gate is required. And intermediate carry, we write it as signals. We write them as C1, C2, C3, and here intermediate signal S1. So we declare all these in the architecture body in the structural style of modeling. And in the architecture body, we also declare the component. So what are the different components required? Exclusive OR gate, AND gate, and a 3 input OR gate. So like this, with this logic diagram, we can obtain the sum and carry. And now we shall see the vhdl program. Before we go into the details of vhdl code, if you understand these concepts, you like, share, subscribe, and comment. Okay, now let us see library and entity declaration. Library IEEE, use IEEE.standardlogic1164.all. Then entity full ladder is, and port A, B, C in. These are the input ports. So in bit type data, sum and C out or out bit type data and full ladder, right? So the components we have to use, and the components used in the architecture should be defined previously as part of the design, or they should be a part of the library. That we have to keep in mind, and then only the program will understand these components. Now let us see the architecture body. Architecture body can be written in data flow style, behavioral style, and structural style. In previous 2 videos, we have seen data flow style and structural, data flow style and behavioral style. Now we are learning how to write structural style of modeling. So architecture, full ladder structural style of modeling. A full ladder entity name full ladder is component XOR gate, and we are these XOR gate, AND gate, and OR gate are defined in the library, and we are declaring component here. Component XOR gate, both X comma Y in standard logic type, Z out standard logic type, end component, and component AND gate we are giving different names. that is port D comma E in standard logic type, F standard out standard logic type, and component and gate. Then component OR gate, this is a 3-input OR gate. So port G, H, I are the input ports standard logic type. J is the output port standard logic type, and component. In this manner, the hardware required is XOR gate, AND gate, and OR gate. They are defined here in this architecture body, right? And then intermediate signals I have shown just now, S1, C1, C2, C3 from the logic diagram. These intermediate signals we define here as a standard logic type. Now let us see the architecture part. Begin. X1 is XOR gate port map with A, B, and S1. Let us see this logic diagram once. X1 is port map with A, B, C, A, B, and S1. Similarly, X2 port map with S1, XOR gate port map with S1, Cin, and sum. In this way, we get final sum. And X3 is AND gate port map with A and B and C1. So A, B are the inputs and C1 is the output. So like that, we port map, we write all these statements as we have seen here. And X1 is XOR gate port map with A, B, S1. And X2 is XOR gate port map with S1, C in sum. And X3 is AND gate port mapped with A, B, C1. And X4 is AND gate port mapped with A and C in as A, C in and C2. X5 is AND gate port mapped with B, C in and C3. And X6 is OR gate port mapped with C1, C2, C3, and C out. And name of the architecture body, that is full ladder structural style. In this way, we write a vhdl program for a full ladder in structural style. In this video, we have seen the what is a full ladder and full ladder logic, truth table and Boolean expressions, logic diagram, and after that entity and library declaration, and then architecture body. Hope you have enjoyed this lecture. If you understand, like, share, subscribe, and comment. Thank you.